If the universe is truly infinite, how could it possibly have an edge? When people think about the end of space, they usually imagine hitting a physical brick wall, but that's not how the cosmos works. This wireframe sphere represents the entire observable universe. We exist dead center inside this bubble, stretching 46 billion light-years in every direction. That outer boundary is the particle horizon, the maximum distance light has traveled since the universe was born. What if we build a spaceship, ignore all practical limits, and fly straight toward that boundary? We quickly realize the edge of the universe isn't a geographic location we can simply point a telescope at. It is a mathematical limit, a threshold we have to try and physically cross to understand. Let's say we fire up our engines and travel at the exact speed of light. We still fail. We will never reach the edge because space itself is expanding, stretching the distance between us and our destination faster than we can cover it. Look inside our giant bubble. Because of expansion, a second, smaller sphere draws a hard line 16 billion light-years away. Beyond this cosmic event horizon, space expands outward faster than light. That creates a chilling reality. The furthest, most beautiful galaxies we observe through our telescopes are actually dead to us. They are ghost images. The light hitting our lenses today was emitted eons ago. In the time it took that light to reach Earth, the physical galaxies themselves have been carried across the event horizon. If we sent them a signal right now, the expanding space would swallow it. It would never reach them. Our visual map of the deep cosmos is an illusion. We are looking at a cosmic graveyard, filled with objects that are permanently disconnected from our reality. So let's cheat. What if we break the cosmic speed limit using an Alcubierre warp drive to travel instantly to the edge? Sorry, Albert, we warp 46 billion light-years in a single second. The result is completely anticlimactic. We don't crash into a wall, we just find more universe. Because the horizon is simply the limit of our vision, it moves right along with us. If you turned around and looked back, our entire Milky Way galaxy would now appear as a tiny, ancient blob of microwave radiation sitting on your brand new horizon. The horizon is entirely subjective. No matter how fast you run or where you warp, you remain trapped dead center in your own inescapable bubble of visibility. If every warp jump just reveals more galaxies, does this go on forever? Or is there a hidden physical limit to the universe? This flat grid shows our first possibility. According to general relativity, on the largest scales, the geometry of spacetime appears perfectly flat. If that holds true, the universe simply goes on infinitely. But think about standing in an empty field. The Earth looks flat from the ground because we lack the perspective to see the curve. Space might be exactly the same. The universe could have a slight positive curvature that sits just beyond our current ability to measure it. If so, a curved universe would take the shape of a hypersphere, a three-dimensional surface wrapped entirely around a four-dimensional sphere. In that geometry, if you kept your warp ship locked perfectly straight ahead for long enough, you would eventually loop all the way around the cosmos and arrive exactly back where you started. Our universe might not be infinite at all. It might just be one finite, slowly expanding bubble drifting inside an exponentially inflating multiverse. The edge of the universe is not a wall we can touch. It is an ever-shifting boundary forged by the speed of light, the relentless expansion of space, and the